Okay, so good morning, everyone. Today we are going to discuss the foundation topic periodic table of class 10. So we are going to discuss some of the important questions related to the periodic table. And based on the questions, I will explain the concept related with the topic. Okay, so here is the first question. The question says, what are isoelectronic ions and account for the decrease in size of following isoelectronic ions? And here they have given certain ions. So first we'll try to understand what is isoelectronic ions. The isoelectronic ions refers to two atoms, ions or molecules that have the same electronic structure and the same number of valence electrons. So if you'll see here, we have defined isoelectronic ions are of different elements having the same number of electrons but different from one another in magnitude of nuclear charge. So that's what I stated. Isoelectronic, it refers to two atoms, ions, or molecules that have the same electronic structure and the same number of valence electrons. So if we'll talk about the particular ions, neon, sodium ion, magnesium ion, aluminum ion. So if we'll see the different examples, suppose we are taking the example of neon atom and sodium ion. In case of neon atoms and the neon atoms and the sodium ion, if we'll talk about the electronic configuration of sodium ion electronic configuration is 2,8. As it was the positive charge, so it loses one electron. Similarly, if we'll talk about the neon atom, the electronic configuration is 2,8. So if we'll see here, the examples which they have given are oxygen ion, fluorine ion, sodium ion, magnesium ion, and the aluminum ion. So if you'll see on moving from left to right in the periodic table, the nuclear charge goes on increasing and the electrons are pulled more and more strongly, decreasing the size of the atoms. So further, if examples, if we'll talk about the neon atom, if you see the neon atom is isoelectronic with the sodium ion, magnesium ion, and the aluminum. So if we'll talk about these four examples, these four examples, which includes atoms as well as the ions that have the same electronic structure and the same number of valence electrons. So they are electronic ions. And based on this, as you are aware, from moving left to right, the nuclear charge decreases. Okay, so we are cleared here with the isoelectronic species. Now we are moving towards the next question. The next question comprises of three different sub-questions. Now, the first sub-question, state the number of elements in the period 1, period 2, and period 3 of the periodic table. Name the elements in period 1. What happens to atomic size of elements on moving from left to right in a period? So we'll solve this example one by one. Okay, now if we'll talk about the first question, the question says, state the number of elements in period 1, period 2, and period 3 of the periodic table. So if we'll talk about the period 1 contains 2 elements. Now, which are the 2 elements which are present in the element in the period 1? The hydrogen and the helium. So you can say period 1 contains 2 elements, if we'll talk about the period 2 contains 8 elements. Now, which are the 8 elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. These are the 8 elements which are present in the period 2. Now, if we talk about the period 3, if period 3 contains 8 elements. Now, which are the 8 elements which are present in the period 3? 8 elements include sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. I'm repeating, period 1 contains 2 elements, hydrogen and helium. Period 2 contains 8 elements. 8 elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. These are the elements. And if we'll talk about the period 3 contains 8 elements. These 8 elements are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Now, we are moving towards the next question. The second question is, name the elements in period 1. That we have already discussed the answer of it in the first, hydrogen and helium. Hydrogen and helium, these are the 2 elements present in the period 1. Now, moving to the question, what happened to atomic size of elements on moving from left to right in a period? Now you know that the atomic size of the elements on moving from left to right decreases from left to right. So these are the important questions from exam point of view based on the periodic table and their elements. Okay, so इसमें ऐसे questions आ सकते हैं कि state the elements in particular periods, name the elements, give their symbols. तो अगर हम लोग element in the period 1 की बात करते हैं, तो there are 2 elements, hydrogen and helium. Hydrogen has a symbol H, helium has the symbol He. Similarly, if we talk about the period 2, lithium, the symbol is Li, boron B, like that. And if we talk about the period 3, the elements are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So sodium ka symbol is Na, magnesium is Mg, aluminium is Al, silicon is Si, like that. These examples can be asked in the exam. Based on this, also they can ask you the questions related with their valence. If we talk about the sodium, you know that the electronic configuration of sodium is 2, 8, 1. So there is 1 electron in the valence shell. Okay, so now we are moving towards the next question, that is the third question. Okay, what the question says, what is similar in the electronic structure of lithium, sodium, and potassium? Okay, now this question we have to see the exact solution of it. Okay, now we have already talked about the electronic configuration. Electronic configuration of lithium, its atomic number is 3. So I can say the atomic number is 3. So you can say the electronic configuration is 2, 1. So if you look at here, the electronic configuration of lithium, I have written it here 2, 1. If we talk about the sodium, it's 11th element in the periodic table. So electronic configuration is 2, 8, 1. Okay, similarly, if we talk about the potassium, it is the 19th element in the periodic table. So you can say the electronic configuration for the potassium is 2, 8, 8, 1. So now the question they have asked is, what is similar in the electronic structure of lithium, sodium, and potassium? So all the 3 have 1 electron in the outermost shell, which they lose to form positively charged species. Now you are aware that any atom, when it loses the electrons, they form the positively charged species, that is called as cations. So if you'll see here the examples, lithium, sodium, and potassium. तीनों एलिमेंट्स के outermost shell में there is the one electron present, and this one electron which is present gives you the which can be easily donated to the other species, and these atoms forms the positive ions. Okay, so this is the question and the solution. We are moving towards the next question. The question next is, okay, the next question is based on the group 17, that is halogens. Okay, now we will see the question. The question is, answer the following questions regarding group 17, that is halogens of the periodic table. Now, if we talk about halogens, we'll see what are halogens. Now, first we try to understand the what are halogens. Okay. Now you know that I have written here halogens are the members of 7A group. Now 7 electrons in the outermost shell. So group 17 elements are called halogens. These halogens is nothing but in Greek it says salt producing. Halogens include fluorine, chlorine, bromine, and iodine, acetylene. They all are non-metals. So if we'll talk about the periodic table, okay, okay. So now periodic table, halogens are placed in the group N periodic table, and group 7A is minus. So if we talk about the elements, their elements are fluorine, chlorine, bromine, iodine, and acetylene. All these 5 elements, they have the 1 electron in its valence shell. Now, if exam they can also ask you the what are the halogens and why they are called. Now you know they are called halogens. Chlorine is halogen in the form of sodium chloride. Chlorine reacts, it produces the salt called as sodium chloride. Similarly, if you talk about another halogens like bromine, iodine, they also forms the halogen. So these are the salt forming compounds. So halogen means salt producers. So group 17 elements are called halogens because halogen is a Greek word which is means salt producing. So halogens include fluorine, chlorine, bromine, iodine, and acetylene. They all are non-metals. And of the important point here, they all are non-metals, so they can easily donate the electrons. Okay, now we are moving towards the next question, that is question number 4, which are here, why do not they occur free in nature? Okay, now you know that they do not occur free in nature because they all are very reactive. If we talk about fluorine, chlorine, they all are very reactive as they need just 1 electron to complete their outermost shell. Sorry, so they can easily gain the electron, not donate the electron. Hence, all the halogens are non-metals. So they do not occur in free nature because they all are very reactive as they need just 1 electron to complete their outermost shell. Every member of the halogen group tries to attain stable electronic configuration. So if we talk about fluorine, the atomic number of fluorine is 17. So what will be the electronic configuration? Electronic configuration is 2, 8, 7. So fluorine requires 1 more electron to become a stable and to complete the octet. So to complete the octet, fluorine requires 1 more electron. So the electronic configuration for the fluoride ion becomes 2, 8, 8 by gaining 1 electron. Hence, their valency is -1. Similarly, if we talk about the another example, fluorine, bromine, iodine, acetylene, they also show the valency of -1. Okay, so now we are moving towards the next question, that is question number 5. That question says, which group and subgroups are they placed in? Now, if we'll see here the question, okay, they are placed in group 7 as I said, and the subgroup is A. Okay, so that is the complete solution of this question. So, and one of the important concept for the halogen is they react with metals to form compounds called salts. So that, also one of the very important. So any halogen when they reacts with the metals, they forms the compounds of salt, or they are salt for the compounds. Okay, so we are moving toward the next question. The next question is, in a group of one of the periodic table, they have placed here three elements in the question: X, Y, and Z have ionic radii. Different ionic radii are given for the X, Y, and Z elements: 1.33, 0.95, 0.60 angstrom respectively. Giving a reason, arrange them in order of increasing atomic numbers of the group. Now we have already seen the periodic table, and you know that in order their ionic radii value increases in order of Z is less than Y is less than X. So if we talk about the of X, 1.33 will be the higher ionic radii in the group 1, which is decreases from left to right. But I have also asked is the increasing atomic numbers. Now we know that this order is due to, if we'll see, just say, here is the question. Okay, so if you'll see the increasing order of ionic radii is given here, and this order is due to the fact that greater is the ionic radii, greater is the atomic number. Ionic radii agar zyada hai to atomic number kya hoga of the element will be increasing, or will be the greater. So as the ionic radii increases, the number of electron increases, and as a result the atomic number also increases. So as we move from the left to right, or if you see the from the top to bottom in the periodic table, the number of shells are increasing. So as the number of shells increases, obviously the number of electrons increases. Number of electron increases, you can say there will be an increase in the number of protons, and as a result the atomic number goes on increases. So in a period from top to bottom, you can see as the atomic number goes on increasing, their atomic size or atomic radii also goes on increasing. So I hope you have cleared with this solution. So we are moving towards the next question. Next question in the periodic table is related with the shielding effect. What is shielding effect, or it is also called as screening effect, and how does it govern the ionization energy of an atom? So if we'll see the solution of it, first we'll try to understand what is the shielding effect. Now if we'll see the solution of it, when the number of inner electrons is greater, then they shield the outermost electron from the nucleus in such a way that the outermost electron becomes free from any nuclear attraction. This is called as screening or shielding effect. Now, okay, so here they have asked what is the shielding effect. Now, we like to know that the shielding effect is when the electron and the nucleus in an atom have a decrease in attraction which changes the nuclear charge. So an example of screening effect is in nuclear fusion. You know that in nuclear fusion, when electron furthest from the center of the atom are pulled up. So shielding effect matlab kya hota hai? Shielding effect is when the electron and the nucleus in an atom have a decrease in attraction which changes the nuclear charge. So as an example of screening effect or shielding effect, you can say is in the nuclear fusion. न्यूक्लियर फ्यूजन में क्या हो रहा है, व्हेन इलेक्ट्रॉन फर्देस्ट फ्रॉम द सेंटर ऑफ द एटम they are pulled away, right? So what, or you can say, how does it govern the ionization energy of an atom? The shielding effect makes the electron very less firmly held by the nucleus on descending group, so the ionization energy decreases down the group. So one of the very important here, always remember, ionization energy decreases down the group. Now how it will exactly decreases, I will explain to you. So you know that the more electrons shielding the outer electron shell from the nucleus, so you can say the less energy required to expel an electron from the said atom, right? So you can say the higher the shielding, the lower the ionization energy, and it is because of the screening effect that the ionization energy decreases from top to bottom within a. So always remember, at the more electrons shielding the outer electron shell from the nucleus, the less energy required to expel an electron from the said atom. So the higher the shielding effect, the lower the ionization energy, and it is because of the shielding effect that the ionization energy decreases from top to bottom within a group. So I'm just explaining again. Here the question is, you have to explain what is screening effect or what is shielding effect. Okay. Now screening effect or shielding effect is nothing but the shielding effect is when the electron and the nucleus in an atom have a decrease in attraction which changes the nuclear charge. You can say an example of screening effect is a nuclear fusion. When electron farthest from the center of the atom, they are pulled away. So the more electron shielding the outer electron shell from the nucleus, and the less energy is required to expel an electron from the said atom. So you can say the higher the shielding effect or the screening effect, the lower the ionization energy. That's what the question asks. So it is now the question is why? Because it is because of the screening effect that how the ionization energy increases or less from the top to bottom within a group. So it is one of the important statement. It is because of the screening effect that the ionization energy decreases from top to bottom within a group. So here you have cleared with the screening effect or the shielding effect and how does it govern the ionization energy of an atom. So we are moving towards the now next question. Okay, now if we talk about the next question, how does the chemical reactivity of alkali metal and halogens vary? Chemical reactions. Now this question is based on the chemical reaction. Now you know that the reactivity of alkali metals increases as we move down the group. Down करेंगे the alkali metals के case में it will be the reactivity will be increases as the atomic number increases. Obviously, as I stated in the earlier question, the atomic radius also increases, right? And the single electron in the valence shell is located further away from the nucleus. Hence, if we talk about the two examples, lithium and francium. Lithium is the least reactive and francium is the most reactive. Okay. Similarly, in the case of halogens, halogens are placed in the what? Group 17, and the subgroup they are placed is A. These all halogens are non-metals: fluorine, chlorine, bromine, iodine, and acetylene. So all of these halogens, in the case of halogens, the reactivity gradually decreases as we move down the. So fluorine will be the, you can say, more reactive compared with the acetylene or iodine. Okay, so the outermost shell and the all of them require one electron, right? If we talk about fluorine की अगर हम लोग बात करेंगे तो 17 electrons होते हैं. Fluorine में भी there will be requirement of one electron to complete the octet. Similarly, in case of bromine and iodine too. So the outermost shell and the nuclear attraction is greater on the nearest shell. अभी nearest shell, if we talk about the fluorine के class में nearest shell कौन सा है? Second shell है. और farthest shell कौन सा है? आयोडीन. जैसे ही हम लोग डिक्रीज सॉरी जैसे ही हम लोग डाउन करेंगे फ्रॉम टॉप टू बॉटम in the periodic table or in the case of halogens, iodine के case में there will be 6 chain is the what nearest chain, right? So hence fluorine is most reactive and iodine is least reactive. Fluorine easily react हो सकता है, iodine easily react नहीं हो सकता. Hence we can say the chemical reactivity of halogens decreases down the group in the case of halogens. Okay, so now we are moving towards the next question. The question is, how do the following change on going from left to right in the period of the periodic table? Give example in support of your answer. We have give the two answers. One is chemical reactivity and nature of the oxides of the element. Okay, so we'll see one by one. Now we have already talked about the chemical reactivity in case of halogens. Now they have asked how do the following change on going from left to right in a period of the periodic table from left to right. Okay, now from left to right, if we'll talk about the alkali metals which are placed on the extreme left in the periodic table. Alkali metals, they are highly reactive. You know that alkali metals consist of the chemical elements lithium, sodium, potassium, rubidium, silicium, and francium, right? Generally, they are also asked you why are they called the alkali metals. You know that these metals which are placed the first alkali metals are called alkali metal because they form alkalis. Alkalis मतलब क्या होता है? Strong bases capable of neutralizing acids. So when they react with water, you can say these metals are called alkali metals because they form, you can say, the alkalis. Strong bases which are capable of neutralizing the acids. And characteristics अगर हम लोग अगर उनके देखने हैं alkali metals के, then high reactive metals not found freely in nature, low melting points, low densities, low electronegativity, low ionization energy and react easily with the halogens. तो देखो अगर हम लोग फर्स्ट एलिमेंट तुम्हें पता है हाइड्रोजन है, obviously it can give the reaction with it can form the reaction with fluorine, chlorine, bromine, iodine. हाइड्रोक्लोरिक एसिड बन सकता है, हाइड्रोजन ब्रोमाइड बन सकता है, HF बन सकता है. So they react easily with the halogens. So the alkali metals are highly reactive. The chemical reactivity of the elements decreases from left to right in the period of the periodic table. So you can say example अगर अभी हम लोग देखेंगे यहाँ पे they have given the example of third period. So now the question third periods में कौन से elements आते हैं? सोडियम, मैग्नीशियम, एल्यूमिनियम, सिलिकॉन. तो पता है कि सोडियम will be the what highly reactive compared with the chlorine, right, from left to right. So as we move from the left to right in the periodic table, the reactivity decreases. So this order of chemical reactivity is the reverse of order of electronegativity. क्यों? क्योंकि electronegativity क्या होता है? Electronegativity of these elements increases from left to right in the period. One of the important chemical reactivity decreases and chemical electronegativity increases from left to right. And if we'll talk about the second question is what of they have asked you nature of oxides of the elements. First of all, try to understand the oxides. Oxides of alkali metals हो सकते हैं, oxides of nitrogens होते हैं. If we talk about alkali metals of oxides, तो lithium oxide है Li2O, this which is one of the lightest alkali metal oxide, right? White solid होता है. Sodium oxide है Na2O, potassium oxide बन सकता है K2O. Similarly, rubidium oxide हो सकता है, right? So they have asked you the question nature of oxides of the elements, right? So if we talk about the periodic table, or if you see the periodic table, the oxides of the elements in a particular period became less and basic and finally becomes acidic in character. So अगर हम लोग थर्ड ग्रुप की बात करेंगे, थर्ड ग्रुप सोडियम है, मैग्नीशियम है aluminium है. These are the elements which are present in the third period. So third period के कौन से oxides बनेंगे? Sodium के साथ Na2 that is strongly basic. मैंने oxides of this element becomes less and basic and finally becomes acidic. तो पहले basic से चालू होगा. तो जो sodium is a first element, तो सोडियम ऑक्साइड क्या Na2O क्या रहेगा? स्ट्रॉन्गली बेसिक रहेगा. उसके बाद अगर मैग्नीशियम ऑक्साइड है, दैट विल बी दी बेसिक इन नेचर. एम्फोटेरिक अगर एल्यूमिनियम, यू नो दैट एल्यूमिनियम क्या बनाता है? एम्फोटेरिक ऑक्साइड बनाता है. फॉर्मूला इज also important concept to discuss is what is amphoteric oxides. Okay, so what is amphoteric oxide? You know, aluminum forms the amphoteric oxide, that is Al2O. So what is amphoteric oxide? Amphoteric acid क्या रहता है? It is an oxide that can act as either an acid or a base in a reaction, obviously. और acid और base का reaction बनके क्या बनेगा? They will produce a salt and water. So aluminium, generally they are forming the oxides are amphoteric in nature. Okay, so generally जो non metals होते हैं ना, non metallic oxides रहते हैं, they are acid and metallic oxides are basic. तो सोडियम देखो, सोडियम, मैग्नीशियम, these are the metals, hence they are forming basic oxides. अगर हम लोग non metals की बात करेंगे तो phosphorus है, sulfur है, chlorine है, right? This forms the acidic oxide. Okay, now the people see SiO2, silicon dioxide, that is acidic, bit acidic in nature. P2O5 is acidic, SO3 is more acidic, and Cl2O7 is most acidic. So what you can say? You can say here from left to right in the periodic table, the acidic character increases or acidic nature increases and basic nature decreases. Or reverse order में from right to left, basic nature increases and acidic nature decreases. So if we talk about this specifically the period 3 में Na2O will give you the strongly basic compound, and Cl2O7, the oxide of chlorine, you will get most acidic compound. Okay, so like that questions may become based on the electronegativity, based on the chemical reactivity, based on the formation of oxides. Okay, अभी ये question पढ़ते पढ़ते there will be हम लोग का एक term आ गया था, the order of chemical reactivity is the reverse of the order of electronegativity. अभी term what exactly electronegativity? So I'm explaining what is electronegativity. Now if we talk about the electronegativity. Electronegativity is nothing but what? It is a measure of an atom's ability to attract the shared electrons. Abhi shared electrons of a what? Covalent bond to itself. Okay, so if the two atoms of the bond are of equal electronegativity, the electrons are equally shared, right? So if one atom is more electronegative, the electrons of the bond are more attracted to that atom, right? So generally they are asking the questions based on electronegativity. Okay, what is high electronegativity? Electronegativity what decreases in classes from bottom to top and increases over time from left to right. So if you see the most electronegative element, कौन से रहेंगे? Fluorine, right? While francium is one of the least electronegative. So generally they are asking the question, this type of questions. What are the different terms used in the periodic table and their definitions, like chemical reactivity, electronegativity, what is amphoteric oxide, acidic oxide, or you can give an example of it. Okay, so I hope you have cleared with this question based on the periodic table. Okay, related with the, and there are many more questions to come in the periodic table. So these questions we'll discuss one by one in the next class also. and their examples also. Okay, so till now we have discussed about the halogens, their halogen families, what are the different halogens, what is isoelectronic species, isoelectronic species, their examples, what are the different elements in the periodic table, different elements in the periodic table, then group 17 elements, why group 17 elements are called as halogens, that's what we have discussed, why. Okay, and the another question, important question we have discussed here, related to shielding effect or the screening effect and their examples, and screening effect, how it will governed by the ionization energy that we have discussed. Then chemical reactivity of different elements in the periodic table that we have discussed. Also the train is what we call as trains in the periodic table, from left to bottom, sorry, from left to right and from top to bottom in the periodic table. So generally they are asking explain the periodic trains with respect to the following points in the periodic table, or in case specifically they are asking for a particular group like halogens or noble gases. Okay, noble gases, you see the electronic configuration of noble gases. So the 10th element in the periodic table, or atomic number 10 is given. If you see the electronic configuration of it is 2 bromide. So obviously this there will be a complete octet. So you can say. Okay, so we'll talk about more in detail in the next class in the periodic table, and we'll discuss some more questions related with the basics of the periodic table and the chemical reactions with different elements like P block elements, S block elements, like